Okay, cool.
Okay. So we said meiosis, one, we're separating homologous pairs. And mitosis, we're not separating homologous pairs. We want homologous pairs to still be there. I still want a pair in chromosome one where one is blue and one is red, right?
Yeah.
Yeah.
So chromosome one, what happens is the blue guy is here and the red guy lines up right under it. So that when they separate, the final cell has, for chromosome one, a blue and a red version.
Mm-hmm.
But in meiosis one, they separate in such a way that when red is over here, there can never be any red on this side anymore.
Yeah.
That so
Yeah.
in chromosome one, they're separating so that the pairs themselves separate from each other.
Mm-hmm.
Does that make sense?
Yeah.
I don't believe you.
No, yeah. I was looking at the picture.
No, because if they lined up like this in meiosis one, if they lined up like this,
Mm-hmm.
and then they separated,
Then yeah, I get it. Then we have one of each on each cell, right?
right? And I don't want that, right?
Mm-hmm.
Because I want there to be the haploid number,
Yeah.
Yeah.
and I want it to be different. Okay.
Mm-hmm.
So that's why in meiosis one, first thing that happens is the homologous pairs first separate.
Mm-hmm.
Okay. I still don't think you're getting it though.
No,
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 yeah.
I get it.
Are you
Here,
sure?
yeah. So first in mitosis, right?
Mm-hmm.
Starting with mitosis, the homologous pairs. Oops, where's the
Mm-hmm.
picture? The homolog basically there was a cell, they separated away where there was one of each in one cell, right?
Right. Homologous pairs are maintained.
Yeah.
Okay.
So, and then when it goes to meiosis, that's when they don't want one of each. Like
Right.
they want that haploid number, right?
Exactly. Because if they had one of each, they're still diploid.
Yeah. So then that's when they get from that homologous cell, you get the that's when it splits up to the when they get pulled apart, right? When you make two cells, right?
Yeah,
Is
you
it?
make two cells.
Mm-hmm.
The result of meiosis one is still a diploid cell because we still have two chromosomes here, two chromosomes here. For chromosome number one, do we had two chromosomes. Yeah, sure, they're both blue, but I still have two blue chromosomes. I still don't get
Mm-hmm.
my haploid number, right?
So that's when we split them, and that's when you end up getting two cells of each, so making it four,
Exactly. So
right?
the first step of meiosis one is just about separating the homologous pairs. Okay.
Mm-hmm. Mm-hmm.
Meiosis two is about actually getting your haploid number. Okay. Now,
Oh yeah.
so meiosis two, you separate your sister chromatids. And mitosis, do we separate sister chromatids here?
No, because they were still together in one cell.
No, we
No,
separate
wait.
sister
No, yeah.
chromatids. Because isn't this a sister
Oh yeah,
chromatid?
because they got one of each. Yeah.
Yeah, they got one of each, but this is a sister chromatid right here, right?
Right.
Hmm. This is interesting. Oh, that's why.
So we still kept the sister chromatids.
Wait 1 second. Give me 1 second, Liz. Give me 1 second. Can you give me just 1 second, Liz?
One
Liz,
second is up.
Liz, Liz.
What?
Give me 1 second, okay?
Mm-hmm.
Let's see here. Where am I? I'm trying to blow your mind right now. What's today's date?
22nd.
Oh, can you give me 1 second, Liz?
Possibly.
Here.
You want one?
No.
This is gonna make for a very boring section of the video if you ever watch it again.
We're gonna be like,
9. But if what I'm trying to do right now works, I'm gonna blow your mind, Liz.
hmm. Let me see that slide. Oh wait, I have. Homologous chromosomes move toward opposite poles of dividing cells during during mitosis, anaphase 1, anaphase 2, or telophase.
What are you talking about?
It's a test question.
What'd you say?
Homologous chromosomes move toward opposite poles of a dividing cell during A. Mitosis, B. Anaphase 1, C. Anaphase 2, or D. Telophase.
Can I read it? The answer is not on here, right?
No.
Huh? Who's doing this?
Mitosis.
I don't know. Let me see.
Okay.
Anaphase.
Mhm.
Um.
So meiosis 1 separated the homologous chromosomes. You see that, Liz?
Oh, they call it anaphase
Which one?
1, anaphase 2 on here.
Meiosis 1
Meiosis
Sorry,
1.
confused.
separated the homologous chromosomes, right?
Say that again. You cut off.
So meiosis 1 separates the homologous chromosomes. You see that?
Yeah.
Meiosis 2 separated the sister chromatids. You see that?
Chromatid. Yeah. Mhm.
Did sister chromatids separate in mitosis?
This you always get me with that question.
Wait,
Dang it.
what? What
Did
is
sister
No, they don't. They don't.
This isn't a sister chromatid right here?
It is, but
Are they not
I mean,
separating?
well, they are.
They are.
Dang it.
Sister chromatids separate in mitosis. That's why meiosis 2 is exactly like mitosis. Sister chromatids separate.
Oh.
Okay. We're going to that centromere and we're busting that up. Okay. Does that make sense?
Yeah.
Okay. Now, meiosis 2 is important because that's what gets your haploid number. But what makes meiosis 1 really important is that that's how we get genetic variation. Okay.
Okay.
because that's where this crossing over phenomenon happens.
In meiosis one.
Meiosis one.
Mhm.
Okay, because those homologous pairs, they line up next to each other, and then one of the arms from one of the red sister chromatids goes to the blue part to the goes over to the blue sister chromatid, and then they overlap, and then they swap pairs. You see that? This right
Yeah.
here.
Yeah.
So now the homologous pairs still separate like they did in meiosis one.
Mhm.
Okay, and then meiosis two still happens, and the sister chromatids still now separate. But what you see now is what happens. All four haploid cells are unique.
Oh, okay, I see. Because some of them have that interchangeable part from the thing, right?
Exactly.
From the
One
chromosome.
cell is all blue, one cell is all red. There's no second cell that's all red, right?
Mm-hmm.
That's
And then
right.
one cell has red tips and a blue center,
Mm-hmm.
and one cell has blue tips and a red center.
Yeah.
See that?
Mm-hmm.
So meiosis one is very important because that's what allows for genetic variation. And meiosis two is very important because that's what gets your haploid number.
Haploid number, yeah.
Okay?
Mm-hmm.
Now, now, you can see that depending on how much crossing over and stuff we have, you can get, you can potentially get a chromosome in a haploid cell that looks something like this. One of the first gene on it is a red gene. The
Mm-hmm.
second gene on it came from the dad, is a blue part.
Mm-hmm.
I'm going to use names, okay? So let's
Okay.
say this is a haploid cell that lives in Susan, okay?
Okay.
So Susan is the person, and this is her haploid cell, okay?
Mm-hmm.
So she has 1, 2, 3, 4, 4 genes, red, blue, and then we'll make the last one, I don't know, red, okay? Does that make sense?
Mm-hmm.
Because you can have not just one, you can have multiple crossing over events. This doesn't happen to have to happen just once or twice. Like it can happen a few times. Okay.
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 So let's say it happens such that she has red, blue, red, blue, red. Okay.
Mm-hmm.
So this is her egg, right? This is her egg cell. An
Okay.
egg cell is a gamete, is a sex cell. We said sex cells are haploid cells, right?
Mm-hmm.
Now,
Gamete, sex cell, haploid.
mhm, this is stuff we've already said. I didn't tell you anything new, right?
Yeah.
Yeah.
So now, when a sperm combines with an egg, we get a zygote, right?
Mm-hmm.
It's fertilized, and that fertilized zygote will start to do meiosis or mitosis.
Mitosis.
Good,
Oh
very good.
no. No. Yes.
Not mitosis.
Oh.
Yeah. It does mitosis, right? Because that's how it starts to form from one cell to two cells, from two
Oh
cells to
yeah,
four
because it
Yeah.
cells,
has
four
multiplied.
cells to eight cells, and then it starts to turn to your little dinosaur baby.
Yeah.
Oh, right? Does that make sense?
Yeah.
Mhm.
Okay. So now I'm gonna draw in here. Let's say this is the sperm coming in, okay?
Mm-hmm.
And it joins in with this egg, okay?
Mm-hmm.
Now, this fertilized zygote is a baby, right?
Mm-hmm.
Let's call the baby, give me a name. All right, I'll give you a name. You guys aren't giving me names. This fertilized zygote is Billy,
Billy.
Billy.
okay?
Billy. Bill.
Billy's mom is Susan, right?
Mm-hmm.
Mhm.
So now, as far as Billy is concerned, okay, when we're looking at it from Billy's point of view, this chromosome that had a piece red, a piece blue, a piece red, a piece blue, a piece red, this whole thing come from
Mhm.
his mom or from his dad?
The mom.
The mom. So as far as Billy is concerned, that's all his mom's chromosome.
Right.
And this black one, as far as he's concerned, that's all his dad's chromosome.
Mhm.
Okay.
That's just how he sees it because this is what he got from his mom.
Mm-hmm.
And this blue is that's what he got from his dad. But when we look at it relative to Susan and we break this and we zoom in kind of here to here, we see as far as Susan is concerned, how did she give that to Billy? She gave it because she had a bunch of like crossing over of her own mom and dad chromosomes.
Oh, okay, okay.
You see that? So
Yeah.
she created this unique chromosome that she doesn't even have in her own somatic cells. Her own somatic cells have one blue
And one
and,
red.
and
But
one
it was in
solid red.
meiosis one where that happened.
Say it again.
So she had the blue and red, right?
Hmm.
But it was during meiosis one when that interchangeable thing happened.
Exactly. So in all of her body cells for chromosome one, all she has is one blue and one solid blue, one solid red.
Mm-hmm.
But because of meiosis, she was able to make a unique combination of a
Yeah.
chromosome because of all the crossing overs.
Crossing over, yeah.
Okay. And then she was able to pass on this like weird Frankenstein chromosome that has parts blue and parts red.
Mm-hmm.
And that's what makes like a kid so much different from the parent. That's why you can have like a short mom and a really tall kid.
Mm-hmm.
Oh, yeah.
You see that? You can have like a mom that has maybe blonde hair, but a kid that has like red hair and freckles.
Yeah.
Mhm.
Okay.
Oh
And that,
yeah, because sometimes like if you have a redhead and it's probably like so like for example, like Ariel, right? Like
mhm.
she's really white,
Yeah,
but me and Dennis are not white.
yeah,
So and then there's nobody white like that in my family.
right. So let me blow your mind real quick. Okay.
Okay.
Let's say Susan had 4 kids. Billy was one of
Mhm.
them. When the sperm combined with this guy over here, we got I don't know, Bob. When the sperm combined with this guy over here, we got Annie.
Mhm.
And then when the 4th sperm combined over here, we got Tom.
And we're talking about this sperm combined with Susan, right?
Yes.
Okay.
These 4 cells are all Susan's eggs. Okay? Egg 1,
Mhm.
egg 2, egg 3, egg 4. And this little lollipop thing is the sperm. Okay? So when it combined and we got Bob, you see how Bob has had one like solid blue chromosome that came from the mom, that came from Susan.
Mhm.
So there wasn't much variation from it. So Bob and Tom, see how it's just solid red? Just like all of Susan's, all of her somatic cells have either one solid blue or one solid red, right?
Right.
Mhm.
So because these guys got passed down just the plain vanilla version, one solid blue, one solid red, Bob and Tom are going to be very similar to Susan,
Okay.
like in
Okay.
terms of how they look.
Yeah.
But Billy and Annie, because they got like the weird versions of it,
Mhm.
of Susan's genes, they're still going to look like Susan, but they're going to have the most variation. The ones
Yeah.
that we expect to be taller, the ones that we expect to have different hair color, the ones that we expect to have different personalities, the one that we expect to have like different differences from Susan are going to be Annie and and Billy.
Okay.
Why? Because they got made from like the crossed over version of her chromosome, the one
Oh.
that she doesn't even have.
Yeah.
Does that
Okay.
make sense?
Yeah.
Are you sure?
Yeah.
Isn't that kind of cool?
Yeah, it is.
All right. Well, I didn't get the blow your mind effect that
So, is that basically what happened in my situation then?
Yeah,
So it was Dennis's.
it could have been Dennis's genes, but the thing is that this is we're all we've been talking about is just one chromosome. This
Yeah,
happens for all 46 chromosomes.
that's freaking nuts.
Yeah, so you can see how there can be so many different possible variations.
Mm-hmm.
And that genetic variation is what allows for like they say evolution. It allows for changes to happen. Like why does this happen in us as a biologic process? Because we're always trying to come up with like a better version and create survival for the fittest. Like we're always trying to come up with a version
That's
that
for
can better adapt to our environment and things like that. But it's also possible that we have like just a simple version too, you know?
mm,
And so Bob and Tom, because they got the simple version of Susan's chromosome 1, they're going to be more like her when it comes to chromosome 1, genes on chromosome 1. When it comes to genes on chromosome 2, on chromosome 1, the other two kids, Billy and Annie, are going to be a lot more different. And they might even show things that the mom never even showed,
yeah.
you know? Like you talked about how a mom can have blonde hair, but the kid somehow had red and freckles. Okay.
Yeah.
And we'll talk about that later. That's how you can have two alleles, like a dominant allele and
Mm-hmm.
like a recessive allele. And like the recessive allele doesn't get shown until generations later. Then all of a sudden the grandkid has something because they're showing the two recessive versions of it. Okay.
You like
What
and
just happened?
yeah, you sounded like a chipmunk. You were like, what
Um,
was that? What are you doing?
Like
I was
it's
like,
speeded up.
I don't know. Maybe it could be the internet connection or something.
yeah, you were like, the mom.
No, no. I was
I'm like,
talking
what
normal
just
speed.
happened?
I was talking normal speed.
I thought he
But
was like
but
that.
you can
I
see
know, I'm
how,
like, dang, Dr.
no, you can see how that genetic variation can bring about different expression of genes that weren't shown earlier. And that's what we talk about in chapter 13 and chapter 14, dominant alleles, recessive alleles, traits, and things like that. How for the longest time everything looked green, 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 then all of a sudden purple. Like how the heck did that happen? It happened because it's crossing over.
Yeah.
Some genes weren't as dominant, but but those properties of that gene kept getting passed down until finally there's an opportunity because of the way things cross over and the way things are expressed for all the recessive traits to show. And then that's what happens.
Mm.
It didn't fully click, I know, but that's okay.
No, 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 I got it.
Are you sure?
Yeah,
Okay. So
that was a
do you
good
see
drawing.
why
Yeah.
meiosis one is important? Meiosis one allows for genetic variation, homologous chromosomes separate. Meiosis two is what allows for the haploid number to form.
Mm-hmm.
Yeah.
Okay, make sense?
Yep.
Mhm.
Okay. So now let's go back to share. All right, can you guys see what I'm doing?
It says
Zoom meeting.
Zoom meetings is using the webcam.
What? Give me 1 second.
Didn't that happen yesterday too?
All right, you guys want me to blow your minds?
We're
Let's see here. You guys ready?
ready.
You don't sound ready.
I'm ready.
How do I do this? Oh, okay. Why don't you guys watch this little YouTube video I found?
Let me see.
You just follow the link
What link?
I put in the chat.
Oh, wait. Okay, hold on. I
you-
cannot believe
Are
this.
you, yeah, I think you can even on this whiteboard, Bridget, you can write on it too.
Which whiteboard?
How do we go back to this? How do we go back to the thing?
Wait, I think we're on YouTube.
Yeah. Are we
Well,
watching
okay.
ourselves?
Wait, click play.
We're on
Long,
YouTube.
long story short, I was able to record it and I was able to publish it to YouTube.
Now.
So you can watch it on YouTube whenever you want.
Oh,
Mm.
what is going on with us?
That's
Okay,
cool.
you blew our
It's-
mind.
It's too late at
Oh,
night.
we're-
You guys are too tired.
That's pretty cool.
So now you just subscribe to my channel and like and subscribe. Leave a comment.
But wait, you forgot to put a little
Leave a
arrow.
comment in the description below.
No, but if like I can post it now. So it's actually better than me just emailing it to you because now it's on YouTube. So you can just literally watch it whenever you have an internet connection.
Why does it keep doing that?
Okay, I'm gonna subscribe, subscribe,
Like and
hit the
subscribe
bell.
for notifications.
Yeah.
Okay.
How do I go back into this? one?
Wait, how many adult maggots are on here? There's a bunch.
Okay,
Okay.
there we go.
So mitosis, okay? So in mitosis, yeah, don't listen to recording me. Listen to me now. Let's say we're gonna just use one chromosome as an example, okay?
Wait,
Wait,
this will happen
who's
with all
playing
four.
that?
Why is there two of them?
I'm not
What?
playing it.
All 23 pairs. It'll happen with all 23 pairs. We're just gonna look at the pair for
You guys are
chromosome
playing
one.
it, not me.
Wait a minute.
So chromosome
Wait, how do we make it
uh,
all?
pair one, we had one blue one from the dad and one red one from the
Bridget,
mom. We
you
had a
know-
homologous pair.
There.
Okay, there.
All right, so that made sense, right?
Yeah,
Yeah. Why is there two? Oh.
over there.
Okay, so now how meiosis reduces chromosome numbers. You have a homologous chromosome and diploid pair, sister chromatids, meiosis 1, it separates the homologous pairs, and then meiosis 2 separates the sister chromatids.
Mhm.
All this makes sense, right?
Yeah.
Exactly what we just did.
Mm.
But first, the homologous part. Before the homologous part crossing over, that's exactly what we talked about.
Mhm.
Okay. Remember
Wait,
here?
what the heck is a chiasmata?
Give me 1 second. Just give me 1
Oh,
second. So remember how we talked about crossing over?
Oh, is that what that is?
Yeah, it's literally that section where they swap pieces. And then remember how we have a blue tip with a red
Yeah.
center and
so the part where they merge is the chiasmata?
yeah, the part over, where's my whiteboard at? Where the heck was my whiteboard? Advanced board. Where the heck was my whiteboard at? This isn't the same whiteboard. I want my old whiteboard.
Delete?
I think I deleted it. No, no, here it goes. No, wait, no, that's not it. Whatever. Oh, here it goes. This, see this orange part that I circled here?
Wait.
The orange part?
That I circled here? That I'm circling now in
Oh,
black?
yes.
Oh,
yes.
wow.
That's the
That's the
chiasmata.
chiasmata.
Yeah.
How do you say it?
I call it chiasmata, but what do I know?
Oh, chiasmata.
Chiasmata, chiasmata.
Make sense?
Mhm.
Mm-hmm.
Okay. So it does all the same. Once you understand mitosis, it's the same
Mhm.
thing. Meiosis one separates the homologs. So you have a prophase one, a metaphase one, anaphase one, telophase one. Same things happen.
Okay.
Okay. Just instead of the sister chromatids separating, it's just the homologous pairs that separate. Okay.
Oh,
Then after
wait,
that,
so wait, there was a question, on that practice exam. It says homologous chromosomes move toward opposite poles of a dividing cell during.
during what phase?
Mhm.
So okay, when do things move towards opposite poles?
Um,
Oh, is that the one that said anaphase?
mhm.
Anaphase.
Wait, let's see. It
So
said phase one.
exactly. Good. You're getting it.
Oh, I didn't get it. I read the answer.
Oh, no, why did you read the answer?
Because I was confused.
Yeah, so you just have to understand it's the same thing as mitosis. So in mitosis, in anaphase, the sister chromatids move towards opposite pairs, right? Opposite poles, right?
Mm-hmm.
Mm-hmm.
In meiosis one,
Oh.
sister chromatids aren't separating. It's just the homologous chromosomes that are separating. So if homologous chromosomes are going towards opposite poles, that's anaphase, right?
Mm-hmm.
What?
Sister chromatids are going towards opposite homologous chromosomes
Yeah,
are
because
going
it's
towards
separate.
opposite poles.
This one's going this
Okay.
You see that?
Yeah, I see it.
So you just have to understand what happens in each one. Prophase, thing like everything condenses, that nuclear envelope disappears. Metaphase, things line up. Anaphase, everything splits. Telophase, the cells do the cytokinesis, and you get the cells that pinch off.
Okay, okay.
Okay, but in meiosis one, what we're separating is homologous pairs,
Yeah.
and meiosis two,
We're separating the sister chromatids.
exactly. Very good. So same thing over here. Now instead we just separate the sister chromatids in anaphase two. Meiosis two is pretty much just like mitosis. The only reason you know this is meiosis and not mitosis is because you see this crossing over effect over here.
Okay, so wait, anaphase two, the sister chromatids separate?
Yeah.
Yeah.
All of meiosis two is just like mitosis. The only reason you know that this picture, if I showed you this picture, how do you know if it's meiosis versus mitosis? Is because you can see the crossing over effect that happens.
Yeah.
And
You
that
can
only
see
happens in meiosis.
exactly.
Meiosis one.
It would have happened in meiosis one, yeah.
Yeah.
But now if I see this and if all I showed you was this picture right, let's see here. If all I showed you was this picture right here, how do you know that this is anaphase two versus just anaphase?
It would be anaphase two. Oh, I know. It would be anaphase two because you already see the
crossing
unique
over effect.
the crossing. Yeah, I
over.
keep forgetting that word. The crossing over. So
Exactly.
that's how you know it's not anaphase one.
No, that's how you know it's just not plain anaphase.
Yeah.
Anaphase one means it's in meiosis one. So don't make that mistake.
Oh,
Yeah.
anaphase one looks like this with the.
That's anaphase one.
Yeah, anaphase one is homologous chromosomes.
Why does it have a blue tip?
Well, these look like separated.
Yeah, because the crossing over happens in meiosis one. So in anaphase one, You're not separating sister chromatids, you're separating these homologous
Oh
pairs.
yeah, I'm so dumb. Okay, yeah.
So you don't call this anaphase one. If this was, if this right here, let's say this red part and this blue part, let's say instead of being there, it was just all red and all blue,
Mm-hmm.
that would be what would it be? What would we call this picture?
If it was all red and all blue,
Yeah,
it would be
just regular plain old anaphase.
okay.
Regular plain old anaphase means it's anaphase from mitosis.
Oh,
If you say anaphase one, it means it's happening in meiosis one. If you say anaphase two, it means it's happening in meiosis two.
So I guess I was confused on because if you look at that picture on anaphase one, why does it have a tip? Why is the tip
Like-
blue?
yeah, it looks like it overlap.
That's what's getting me confused.
Yeah.
What, this right here?
Yeah.
Uh-huh.
You
Oh,
see
because remember we said that the crossing over happens before these guys split up.
Oh. Oh yeah.
Let me do
yeah, they happen in the metaphase, right? When they
Yeah,
align.
it happened in metaphase. Like, look,
Yeah,
look,
when
look,
they
look.
align next to each other.
Look, can you see what I'm showing you here on the whiteboard?
Wait,
Where at?
we can't see you.
Can you see me here with the
Oh
purple?
yeah.
Yeah,
Mhm.
this right here. See how
Yeah.
they lined up next to each other and then they crossed over?
Uh-huh.
Then we see the crossover effect. Then they split.
Oh
Mhm.
yeah.
They crossed over, they switched parts, and then they split. This right here, when they split, is anaphase. So they split once the crossing over actually happened. The crossing over happens when they line up next to each other for metaphase one.
Okay, so
Then in
next,
anaphase one, these homologous pairs, they split up after they've already swapped parts.
okay, so they swap parts before anaphase one
Correct. In metaphase one.
in meiosis one.
Mhm.
So okay. Okay.
Less than 1 minute left.
Oh my god.